Hello, everyone. Welcome and thank you for joining our series of podcasts. It's all about the data podcast. What we are doing here is we invite top industry experts, to join us for a short session where they share their knowledge and their best practices. And today we have Daniel, founder of Quality Match. Quality Match helps data science teams to measure, improve, and ensure data quality for training machine vision AI. So, what we will do right now, Daniel, would love you to introduce yourself a little bit, and we go through a series of topics that we would like to cover today.
Yes, thanks, Maria, for having me. I'm Daniel. I did have a long journey behind me. I started out as a computer scientist, studying AI. I was super hyped about AI a long time ago, somewhere in the late 90s. And that brought me to doing a PhD thesis, and that brought me to getting habilitation. And now I'm in what I think it's called in Germany, it's called Privatdozent. In English, it's something like associate professor, which means I can also graduate PhD students. And I've always been trying to understand how computer vision works and what you can do with AI. And I'm a huge fan of the topic, so I was always very driven on that. And then, like 2012 or so, I had a company called Palace Ludens, and that was super successful. In 2016, I think I joined working at Apple. I had a small data science team there, and we were working a lot on like data set quality and stuff like that. And in 2019, I just couldn't stop myself from founding a new company, and that's Quality Match, what you just mentioned.
Amazing. Well, that's like a pretty impressive background.
Thank you.
Amazing. So today I would like to ask you some questions about data, and the most, I would say, important and painful topic when it comes to training AI models is how do you ensure the quality of the data, or how do you even measure the quality of the data, or even going like one step back, like what is quality of the data? Maybe we can start from the question is what is quality of the data? Like why is it important? Like what is it?
Oh my God, I can talk for like 10 hours now and never get
15
back.
minutes.
So the question, what is quality? That's actually always been my research field, right? So how performance and evaluation, and what do you do in order to understand what it is? And one thing, what it is not, is a single number. And I think that's super important. You cannot say my data is good or bad. You have to say my data is good with respect to a certain aspect. And the quality of data can, for example, be if it's about detection of objects in images, then you could say there's a lot of hallucinations, a lot of false positives. That could be one metric which you can measure. And there are many other metrics, and every metric has a different impact on the application you're using in the end. So if you say, I want to train autonomous driving, like cars maybe not crashing into another car. You need to detect vehicles, so you need a vehicle detector. And then the question is, what is good data? It's becoming super complex, because if the vehicle is super far away, it doesn't matter, you're not going to hit it. If the vehicle is coming towards you on the other lane, it doesn't matter, because you cannot change lanes so easily unless you have a big accident. And so suddenly it's not just, is the box missing or is there a box too much? It's more about where is it missing, how much too much is it, and so on. And this is why in every case you would define your own quality assurance process and your own understanding of what are the necessary metrics for your actual use case. And actually there just is a new ISO standard which should come out maybe this or next year. It's called ISO 5259. It's about quality of data for machine learning. And there are a ton of metrics in there which are a great starting point to understand what is good and what is bad data.
Okay, but if you would to summarize, so basically defining what is quality is like a whole process or a whole topic of itself. But if you were to summarize right now for startup that's working on a certain AI model, let's say automotive startup that wants to recognize objects, recognize lanes, recognize surrounding, like how would you approach the definition of the quality of the data, like in simple terms?
Yes, in simple terms. So to
Yes.
start with, just to say again, it's complex, it's not simple, but if you have to really make it very simple to begin with and to get a gist, you would do the following. Let's say you do detection, 2D bounding box detection for any kind of category in autonomous driving. You typically have four categories of errors. One is false positives, that's objects that you're hallucinating. One is false negatives, that is objects which you are overlooking, which you haven't seen. Then there's geometry correctness, which means the bounding box is, for example, tight or isn't too large or something like, or too small. And the last category is an attribute error. So for example, you might want to know how much is the object I'm seeing occluded. And if that is a correct value or not a correct value would mean that there's another metric. So four categories of metrics which you can start with, and they are all kind of intuitive to begin with.
I see. And would this method apply to automotive only, or this is something that's cross-industry
It's
applicable?
definitely cross-industry. It is computer vision. It's mostly focused on computer vision. So if you have language, it might be different. And if you have, for example, text data or sequential data, like, I don't know, like ECG curves or something like that, it would be a bit different probably. But in general, you will always come to such a rough categorization of quality metrics for
Okay. Well, thank you for the explanation. So, based on that, like how, like what methods or strategies are currently used to ensure the quality? Basically, after we defined what it is, how we can ensure that it's actually present in our data set.
So typically what you do when you want to create a data set, you create something like a label guide or label specifications, which is a long text which says this is the things we want. So for example, we want to find vehicles. We would say this is what we see as a vehicle. It's not a plane, for example, or not a ship. We're actually looking for cars and trucks and stuff like that. And this kind of the document. This document is normally pretty long. It can, like, for example, for traffic signs, it can be like 70 different pages of text. In order to do a proper quality assurance, you would normally really need to have a deep understanding of this label guide. And what's currently being done is that there's a person who is very, very familiar with this. They really read this through, and then they see the annotated data. So you see maybe an image, and there are a lot of bounding boxes of traffic signs or vehicles. And it's a whole image, and maybe there are 20 or 30 different objects with bounding boxes or with segmentation, with contours around them. And then the person who knows this label guide by heart and is very familiar with it, they will go through all of the aspects, like what are the false positives, what are the false negatives, what is the geometry correctness, what does it mean, and they apply it to every object. And that approach is problematic because it's impossible to be perfect in this. If you have to remember like 70 pages of text, and then you have to be there and really understand that you have to apply these 70 pages of text on every object in the image, and there's like 30 objects. How can you be sure that you did not miss that one object which is on the side of the image? And the problem is this is also not auditable. And with the upcoming European AI Act, there are new rules on how you need to evaluate the quality of data sets. And to make it auditable, you really have to go an extra mile. So right now the process is very simple in the sense that you have an expert, and that expert looks at the image and looks at the label guide and then gives you a thumb up. It's good. And that's what I have problems with.
Okay, so I guess that's a very good point to kind of look into quality match and how quality match solves this problem.
Exactly. So the idea with quality match, or I think you can even abstract it from quality match. I think the idea is, how does a perfect process look like for quality assurance? And you very quickly get into the domain of statistics, and you get into a situation where things become prohibitively expensive. You could say, if every person in the world looks at every object 10 times, then we can be sure that everything is right, right? And then you have perfect quality, maybe, but that's impossible. So you have to make trade-offs. So you always have a trade-off between the cost and the quality guarantees you can get. And that's a trade-off, the number one trade-off. And the second thing is, you might only want to look at categories which are really, like at errors, which are really important to you. So you might want to break it down. And then you want to make sure that you actually know what you looked at and that you can be sure. So that means if you bring all of this together, you will inevitably come to some sort of process which is similar to what we do at Quality Match. And the general idea is that you break down this long label guide of 70 pages and you bring it to a very small, what we call nano task. So very simple question. For example, if you want to understand is there a pedestrian? You might have 10 pages of text explaining what a pedestrian it is. It could be, it's not a police person. It is not a construction worker and so on, right? There are a lot of, or it's not a bicyclist. But what if the bicyclist is pushing their bike? And then you're like, is that a pedestrian or is it still a bicyclist? So it's very complicated also to define that. And what we do is we break it down into such simple questions that can be answered by anyone with almost no extra training. For example, we would always begin with the question, is there a human being in this bounding box? And then you can understand if someone says, no, it's not a human being, then it's also not a pedestrian. And then you can use this information as a starting point to branch. And it's what we call it, what's a decision tree? I mean, we call it a decision tree, but it's also by definition a decision tree. And then the next question could be, if people say, yes, it's a human being, we could ask, is this like a group of people in this box, or is this actually a single person, and so on. And then this way you can move step by step. And you can find out at which point there is an error maybe in the label guide. So because the label guide could say only label individual people and not groups, or do not do police people do not create a police people bounding box or something like that. And the second aspect is, which is also super important, is that you repeat the question to multiple people. So
basically
you would
consensus.
exactly. It's a mix. The thing is, how do you know that if you ask 10 people and 7 people say yes, it's a person, and 3 people say it's not a person? How do you know that the consensus is that it is a person because 7 people said so? And fun fact, there is statistics behind that. So you can say the question, a yes/no question, can be modeled, and now it's very technical, a binomial distribution. That's a statistical term, and that has this likelihood, right? You can say 7 people say yes, 3 people say no, so it's 10 people, so I guess 70% are voting for yes. But the trick is, because you only asked 10 different people, there's an uncertainty. You don't know if it's exactly 70%. Maybe if you were asking many, many, many more people, it would maybe be 60% or 80% or something like that. And this is something you can also model statistically. There's a lot of statistics in the realm of clinical trials, for example. So when you have a new vaccine in COVID times or something like that, you cannot test it on every person in the world. And so there's the same kind of problem, fundamental problem. And that's what we put into our software and solve it automatically. So we keep on asking people, and at some point we decide we have asked enough people because there's enough statistical power in the answer, and we can trust the majority of the agreement of the answer which has been voted most for.
Okay, so but what's the difference, for example, between using quality match with the system and doing this in-house with our own people?
Actually, first of all, it's super cumbersome. If you do it in-house, you have to have a tool, I think. And if you don't have, like, it's difficult to build that tool. You have a decision tree, you have these questions, and if you want to ask the question, you very often visualize the object in a special way. So maybe it's a 3D bounding box, and you want to project the 3D bounding box from the 3D point cloud into a 2D image, and then ask, is this actually a car in this box or something like that? And that's the other thing. And then if you want to do the statistical aggregation, you need to stop at some point. So you need to know the underlying statistical methods and need to implement them. And then you have to branch in the tree, and then you have to come to a conclusion, and then you need a tool to visualize the results. And all of that is something you can, of course, do in-house, but you have to essentially build a big set of tools, which we've already built. So things will be much easier if you just use our tool.
I see. Yeah, that makes sense. Awesome. So what you would say, like looking at the set of tools that you created, what you would say that it's unique and makes it different from whatever else is out there right now available in the market?
I do believe there is nothing in the market which does exactly what we do. So there's essentially there's another component I haven't mentioned yet. So there's these 3 components, right? The first component is how to visualize the task in an image and ask a question about it in a smart way. That's the first element. And that's something you would configure with our tool. But you could theoretically do this in any label tool. Then there's the second element, which is all about the question of how many repeats do I need to do? And at which level did I do enough repeats to have the necessary statistical power to move to the next element and put this in a decision tree? That's something which is super rare. I have not seen this yet. I know that there are a lot of tools which have a majority vote, which say, like, I asked 10 times and then 8 people say yes. So the answer is yes. But there's no statistical analysis behind that, which is automated. That's what I see some tools which are going in this direction, but it's relatively rare. The third element, and that's really unique, and I have never seen this before, is that you can automate this element. So once you have a visualization and you have the repeated questions from multiple people, what we can do is for every data set, for every visualization, for every question, we can train an AI model which is able to predict not what is the right answer. It will predict how much are people going to disagree over this. So we
Aha,
have
interesting.
essentially, yes, we are building a model for each of these questions, which essentially tells you this seems to be an easy task and you can trust me, the model,
Uh-huh.
or I'm pretty sure that people will disagree over this, so I'm not the one to make a call.
Aha. Okay. So basically, you're eliminating like complex cases, like you're kind of trusting the easy cases and basically easily not eliminating, extracting like complex cases that needs
Yes.
extra attention.
Yes, and fun fact,
Yeah.
this is super effective. It's crazy. Like we were actually surprised ourselves. If you have these nano tasks where you already have this visualization and a
Yeah.
very simple question, the automation works to a level that very often you can automate like 90% of the tasks and you get 99.9 level of accuracy. Like you have really almost zero errors. And the remaining tasks, which are very ambiguous, where you like predict that people are going to disagree, what's interesting there is some of these tasks can actually be thrown away. Everything that's super ambiguous will actually hurt the model training. We have just shown that in a CVPR paper, like in an academic conference.
That's
Yeah.
actually very interesting from our experience. The data sets that we get are usually those complex, ambiguous tasks, and what the request that we receive is okay, like annotate those complex tasks because they're so ambiguous. Our model failed, and we want to train all those ambiguous tasks. So
Yeah.
that's exactly the opposite of what
Yes.
you are suggesting. That instead of processing them, we should like throw them out.
I would say there's a gradual decision to be made. So there are tasks which are super easy and they are also
Yeah,
not good for the model because it's just biasing the model.
yeah.
It's too simple. Then there are tasks which are super hard, which you should actually throw away because it makes no sense. Sometimes I see like there's a small box and there's supposed to be a pedestrian in there, but I just see a couple of pixels which are super blurry. And if you ask 100
Yeah,
people, everyone will be like, yeah, how should I tell? It's impossible.
yeah.
So that's really not useful. But there is this in-between element.
In
There's
between.
the stuff which is kind of complex, but not too complex. And that's the interesting part. And this is where you still need humans. And also this is where all of the interesting edge cases happen. So for example,
Yeah,
if you
for
ask,
sure.
is this traffic sign a triangle or not? And then there's some traffic signs, like there's a German pedestrian walkway traffic sign, which is blue. It's a blue rectangle. And inside the blue rectangle is a white triangle. And a lot of people disagree then. If you ask, is this a triangle sign? A lot of people would say, yes, it's a triangle sign, obviously, because it's a white triangle on a blue rectangle. And other people will say, no, it's a rectangular sign because the shape is rectangular. And then you have an edge case. You're like, okay, maybe I did ask my question not in the best possible way, or maybe I need to look at this specifically. And this you find in this high ambiguity category, which is not too high. And that's where the magic happens, so to say.
Interesting. No, that's very, very interesting approach.
Yes, I love it
Amazing.
too. I'm always super excited about it actually.
Yeah.
And we've been using this for a couple of years now, and I'm always like, oh my God, this works really nicely. And it's sometimes the automation, the AI part, I'm actually surprised because I wasn't thinking that it's so.
Amazing. Well, very, very exciting.
Thank you.
Okay, so I think we are running out of time for our session. Is there anything else you would like to share, or maybe a recommendation you could give anyone who's working on
I think I
ensuring
think if you,
quality for models?
yes, absolutely. I think there's
Yeah.
one thing I want to encourage everyone to try is don't try to treat ground truth like training data as it's the ground truth because there is always ambiguity involved. And I think you can also train the model with the knowledge on how ambiguous the data is. So the model can say by itself, I'm not sure if this is a pedestrian or not, because there is ambiguity in this image. And it doesn't just give you the prediction on whether it is a pedestrian or not. It also gives you a prediction on how much people are going to disagree. If you breed that into the application, instead of we're using this in our tools, But I think you can use that signal, that ambiguity signal, which is not a classical network confidence, right? Network confidence score is a very technical thing that comes out of the network. But what we are predicting is how much are people going to disagree? And you can use that in your own model, in your own application. And I'm very sure that this is going to boost the quality of the application. And haven't seen this much neither in academia nor in actual applications. So I really encourage everyone to try this out because I think that will be the next level in quality for AI models.
Yeah, that's very, very good point. Thank you so much.
Thank you very much.
Well, Daniel, thank you for all this amazing input and information. And, we'll definitely talk again.
Sounds great. Thank you very much for that.